Okay, guys. So, hello again. So, this is another lesson, and this is entitled Newton's Laws of Motion. So, maybe some of you are familiar with the laws of Newton. So, but in this case, we will be discussing this one. So, we will be discussing each law, and we will be having an examples of how these laws of Newton's work. Okay. Okay. So uh, let's try to go back from our previous studies, from our previous lessons. Okay. So lahat ng nadaanan nyo from start to finish. Okay. So and let's try to incorporate these laws. But for now, let's start with our first law. This first law is entitled as the law of inertia. So an object at rest will remain at rest, and an object in constant motion stays in motion and direction unless um, acted by an unbalanced force. Okay, so let's try to look at this video. Okay, so this is a short video. Okay, so as you can see, there is an object, the resting object. And let's see what's gonna happen. Okay. Guys, look at this one. So this guy right here is pulling pulling this object. Okay. So there is a tons of candies, and there is a speed indicator on how fast this object is going. Okay. So when you look at this guy is this guy is pulling the this resting object, but as you can see, there is a force applied in here, and this guy is, we can call this guy as the imbalance force. Okay, this is the guy, that guy is known as the unbalanced force. So why is it unbalanced? So guys, as you can see, there is nothing, there is no force, acting on the other end of the object. So if that object is resting, then when this guy pulled that object, there is an unbalanced force acted on it. So this is what the law of inertia. So an object in motion stays in motion, but an object at rest will remain at rest. Okay, will remain at rest. And since as you can see, the guy is still pulling, then the object will be in constant motion. Okay, so this is what the first law of inertia is. As you can see, there is the guy that being the unbalanced force, because the object cannot move or will not move if there won't be any unbalanced force acted on it. Okay, so it will not, an object will not stay in rest if someone push or pull the object, so it will not stay at rest. So that guy is what we call the unbalanced force. So a person can be an unbalanced force kasi we're the one who are going to move the object. Okay, so the next law is what we call the law of mass and acceleration. So the acceleration of an object is directly proportional to force applied to the object and is in the same direction of the force. Okay, so let's try to to watch this one again. Acceleration of an object is directly proportional to the force applied to the object and is in the same direction of the force. Okay, so let's watch this one. Okay, so as you can see, this guy is pushing. There is an applied force, and as you can see, the direction of our guy, or the direction of our guy and our object is in the same direction. So all the forces applied in here, the mass and the acceleration is all going to the right. So if the guy is pushing, then the applied force is on the pushing direction. So this pushing direction is going to the right, then the applied force is going to the uh, right side, and so is our acceleration. So let's try to play it again, once again. Yes, guys, look at this one. So the person and the object is all going to the right. Okay? So yan, napasplit pa. Napasplit pa si Koya. Okay, so but all in all, as you can see, guys, uh, the acceleration, the acceleration of the object is directly proportional. Okay, so as you can see, directly proportional to the force applied to the object and in the same direction. So we just seen a while ago that this is the force applied, 200 newtons, and the sum of the forces is also 200 newtons, and all are going to the same direction. So there is no pushing action, and the result will be a pulling action. So it won't happen. It will not happen that you push an object and then the object suddenly goes to your direction. It will not happen. If when you push an object, it will always going to the direction where you push the object. Okay, so if you pull the object will directly go to where your pulling direction is. Okay, so kung pinul mo siya, the direction of the object is on a pulling direction. So, ibig sabihin, kung hinila mo palapit sa'yo, ibig sabihin, the object will also come forth. Okay? So, that is the law of mass and acceleration. So, we're just going too fast. So, this is just easy, guys. So, this is just a recap. Okay, so there you go for our law of mass and acceleration. So we have here a formula, mathematical formula, which is which was told by our Newton's law, second law, that force is directly proportional to our acceleration. Force applied. The acceleration is directly proportional to our force applied. So this one is what we call, this one is the proportionality symbol. Proportionality symbol. Okay, so when we talk about proportionality symbol, it is not a mathematical operating symbol. Okay, so it's not an operating symbol. Okay, so it is not an operating symbol. Okay, so what are those operating symbols? Those are the equal, the plus, the minus, the multiplication, and the division. And also, pwede din natin incorporate ang square root. So, these are the symbols that are operating, but this one is not operational. So, sir, why is it not operational? Okay, so why is it not operational? Because proportionality symbol only indicates the proportionality of an object, of values. Okay, so for this um, we will be discussing about the force and the acceleration. So it is said that the force applied is the acceleration is proportional, directly proportional to the force applied to the object. That's what the second law of uh, motion is. So the force, that the acceleration, the mass and acceleration, force and acceleration, proportional to each other. Okay? So if it is proportional, so this is direct. If we're going to make it an operation, so this proportionality symbol, if we're going to wish to use it in our mathematical operations, we have to convert the proportionality symbol into an equal sign. Okay. But this proportionality symbol doesn't require to be converted directly to our equal sign. So this is not equal. These two. Okay. So those two is not equal. So what is equal is the proportionality symbol is equivalent to an equal sign and a constant. Okay? So this is equal. So there is a constant for our proportionality symbol. Okay? So for that constant, mass is going to take place. Okay? So this proportionality constant is what we call the mass. Only for this instance, the force and the acceleration. So that mass is not really constant per se, but it is a constant. It's a constant. What do you call this one? Constant part of the formula. Okay, so that formula will be always having a mass. Okay, so that is the constant component of our formula. Okay. So now we will be having a formula of force is equivalent to mass times the acceleration. When we talk about the constant in this formula, it is not the constant like the gravity that is always 9.8. So when we talk about this constant, mass is constant because that is a that component, the mass component is really part of the formula. Okay, so it is really part of the formula. That's why it is constant. Okay, it's not constant in value but constant in its use. Okay, constant in its usage. Okay, so let's try to have this example. So find the force of an object having a mass of 5 kilogram and moving with an acceleration of 2.12 meters per second square. Okay, so for the solution, we have a formula of F is equals to ma, mass times the acceleration. So substituting the values of our mass and our acceleration, we will be having a force of equivalent to 5 kilograms multiplied to 2.12 meters per second square. And we will be having a value of our force which is 10.6 Newton. Okay, Newton. Okay, so this kilogram multiplied to meters per second square. Okay, so this the unit of mass, which is the kilogram, and the unit of our acceleration, which is meters per second square. When you combine these two, when you combine these two, we will be having a unit of Newton. So the unit of the force has a unit of Newton through the combination of kilograms and meters per second square. When you combine those two, you will be arriving at the unit of Newton. Okay? So, okay. So next, let's proceed. So I hope guys that the force which is equivalent to mass and the acceleration is understandable. So it's just easy. Force, always remember that force is equivalent to mass and the acceleration combined. Okay. So it's very very easy to remember since all force has a mass and you cannot produce force without any acceleration. Okay. So let's try to move on to our last and our third law of motion, so which is known as the law of interaction or the action reaction law. So, okay, for every action, there is an equal and reverse or opposite reaction. So, ito yung ating ibig sabihin dito. For every action, there is an equal and opposite reaction. Okay. So, yan, guys. Okay? So as you can see, we have four people on this side and another four people on the other side. So as you can see, those four people are applying the exact same forces. Okay, so for the left force, we have 350 newtons and on the right force, we have also 350 newtons. So both group or both teams are applying the exact amount of force. Okay? So what's gonna happen when we play this one? Okay. So guys, as you can see, both of these groups are pulling, but none of them bulge. Okay. So why none of them bulge? Because for every action, there is an equal and opposite reaction. Okay. So since both of these are producing same amount of force, for every action there is an equal and opposite reaction. Equal and opposite. Okay? Equal and opposite. So none of them will be moving. Okay, so but what's gonna happen, sir, if we remove one of these people in the equation? Okay? So let's move. Okay. Let's see. Nagtanggal ng tao, remove two people, and voila. Guys, as you can see, the object move. Okay? So, if it is unbalanced, there is the force is not equal, the action is not equal, then the object will move. Okay, the object will be moving. So if this object move, then this one's going to the first law and the second law of motion. Okay. So sir, why are we going to the first law and the second law of motion if the object moves? For the reason, guys, that if an object moves, there is an unbalanced force. Okay? There is an unbalanced force. Okay, so if the object also moves, so the applied force is directly proportional to the acceleration. Okay, so kung saan yung force mo, doon din yung acceleration. Okay? So that's why when you break the third law, it will fall onto the first and onto the second. Okay? So as you can see in this simulation, when the object was moved, when the object was pulled, there is an unbalanced force. If there is an unbalanced force, it will move. Okay? And also, when you are moving, the forces is going to the right, then automatically, the acceleration is also going to the right. Okay? So, any questions regarding this? Any questions regarding this? Okay. So if you don't have any questions regarding this, so let's move on to our next slide. Okay, so mass and weight. Okay, so mass and weight. So first of all, mass is known as the overall content of the body. So regardless of where you are, your mass will be your mass. Okay? Your mass is your mass. When we say your mass is your mass, um, that is the content of your body. Okay. So if you add something, then if you lift something heavy, your mass will be the same. You just added some mass because of the object you just lift, but your mass is your mass. Okay, nothing's changed. Okay, unless you eat and you accumulate some of the foods and stored in your body, so your mass is be adding. But when we talk about mass, it is constant. If your mass is uh, 55 kilos right now, maybe later on it will still be 55 unless you don't eat. Okay, mass is mass. Okay, it's a constant value for yourself. Okay, so this is the overall content of a body. Okay. Okay. So next is the weight. Okay. So weight normally when the misconception of the weight when we talk about weight is pag tinanong ka, what is your ano yung timbang mo? So sasabihin nila. So normally when we talk about weight, it is timbang. Okay. But most people don't know is that when we talk about weight, gravity is incorporated. Gravity will enter the conversation because you cannot say that your weight is 55 kilograms because that is your mass. Okay, so when we talk about weight is 55 kilograms multiplied to the gravitational acceleration. Okay, so this is the example for our mass and weight. So when we talk about mass, uh, okay, so when we talk about mass and weight, okay, whenever you are, okay, so this is not a question of whenever because none of us been to space. Okay, none of us been to space unless you're super rich or you have connections that you can and maybe going to the outer space. So outer space has a gravity-less environment. Okay, so whenever if you go to space, you will have no weight. Okay, you will be having zero weight. Sir, why? Because weight is applied if gravity is present. Okay, so if it is present, then you don't have any weight. So how about mass? When we talk about mass, even if you are on the moon or on other planets or outer space, then your mass is your mass. That's why I told you this. Your mass is your mass. Kung ano yung meron ka sa katawan mo, if your body has 55 kilograms, on the moon, on the outer space, on Mars, on Pluto, on Mercury, on Earth, you will always be 55 kilograms. Your mass is your mass. Your content is your content. Okay? The content of your body is inside. It's not incorporated with gravity or anything. It will not be incorporated with anything. Mass is mass. Okay? If it is only present. It is present. It is present even though gravity is absent. Okay. Okay. So yeah, contact forces and non-contact forces. When we talk about contact forces, these are the forces uh, that are in action if there is contact. So from the word itself, contact and non-contact forces. So one of the examples of contact forces is the normal force. So next is the friction and the tension. Okay. So when we talk about normal force, it is a force that is acted even though you are just standing, even though you are pushing or pulling. Normal force. Okay. Okay, so from our examples a while ago, the simulation, so all of those are normal forces. Those are all forms of contact forces. Okay, the pushing action, the pulling action, so all of them are contact forces. The object that stays in rest is an example of our normal force. Okay, normal forces. Next is the friction. Okay, an object a while ago that we are pushing on our second simulation, which is the mass and acceleration simulation video, that pushing action is having a friction also in there because the object and the surface are in both contact. If those are in contact, then there is a friction in there. So friction will be further discussed on our next video. Okay. So and for the tension are normally found on springs, on ropes, on chains. As long as there is a pulling or pushing using those strings, there will be tension. Okay, so tension is not tension that makes your heart pound. Okay, your heart pound. No, that's not the tension that we're talking about. The tension that we're talking about here is the tension between the object and the rope or the string attached to it. Okay. So next is the non-contact forces. These are the forces that don't need any contact at all, but still force is still in effect. So when I talk about non-contact forces, some of examples here are the magnetic force, gravitational force, electrical force. So electrical force, even though you don't have any connection, the electricity jumps into one object to another, and there is force applied on it. Okay, so the gravitational force, it is easy because gravity is doing it right now. Okay, so even though we don't have any contact with the gravity or the sun, still, or even the earth, we don't have contact. So sir, why don't you have any contact with the earth? Because I'm on the second floor of my house. Okay, I'm on the second floor. Okay, so if I'm on the second floor, so you're not connected to to the earth. Okay, so but your house is connected, so still gravity is in effect. Why? So try to jump. So because you land on the earth or on the ground, then gravitational force there is applied. Okay, so and lastly, the magnetic force. So when we talk about magnetic force, sino ba namang hindi nakakita ng magnet? So I know, or I guess some of you or most of you or all of you have seen magnet and know how magnets work. Okay? So, okay. So that's it. So that's for today. That's our lesson for today. I hope guys that you enjoyed I hope that you enjoyed this video, and midterms is upon us. I hope that you all are well prepared. Okay, so thank you guys for attending the class, and I hope to see you soon. So this is all for today. Newton's laws of motion. God bless, guys. See you and God bless. Bye. Thank you. Stay safe all the time.